In this lesson, we're going to be working with matrices. And a matrix, if you look down on the vocabulary, is an arrangement of numbers, and they are in rows and columns. When you do a matrix, we are worried about the dimensions, which is the measurement or how we are going to assign numbers to a matrix. And so it's rows first by columns. The rows are signified by the M, and the columns are signified by the N. Entries are elements. That is each individual number that's in the matrix. And equal matrices have the exact same dimensions, and their corresponding elements would be identical. So the first thing that we're going to talk about is to tell whether matrices are equal or not. So in this first example, first of all, this matrix measures 2 rows by 2 columns. 2 rows by 2 columns. So their size is exactly the same. When we take a look at their entry or elements, 2.5 is the same thing as 5 over 2 or 2.5. Negative 0.2 is exactly the same thing as negative 1/5. And then we have negative 1 and 3 being the same. So this first set of matrices are equal. When we look at the second set, even though their dimensions are the same, which we have a 2 by 2, their entries are not equal. So these would not be the exact same thing. So when we talk about an entry, this entry is in the first position, which is in the upper left-hand corner, and they are not the same. Likewise, the 3, which is in the lower left-hand corner, is not the same as the 8, which is in the lower left-hand corner. We are going to talk about how we do basic operations with matrices. The first is how we add matrices. When we add matrices together, they must be the same exact size. So when we take a look at this first matrix, it has 3 rows and 1 column. This matrix has 3 rows and 1 column, so they are the same size. Then the adding part is very easy. We simply add the exact same positions together. So 0 plus 1 would be 1, and we write our answer in the same size matrix as the ones that we are adding together. 4 plus negative 9 is negative 5. 3 plus 8 is 11. So we have added those two matrices together, and that's our answer. To subtract matrices, we do the exact same thing. They first have to be the same size. This one is 2 rows and 2 columns. This one is 2 rows and 2 columns. So they are the same size. They can be subtracted. So we are going to subtract each of the elements. So 3 take away 2 is 1. And the answer goes in the same position as when we were either adding or subtracting. Please be careful with the negatives. 9 take away negative 3. Remember, take away a negative is plus. So 9 plus 3 is 12. Then we have 3 minus 0. 3 minus 0 would be 3. And then we have negative 5, take away 5. Negative 5 take away 5 would be negative 10. In the next one, the measurement of the first matrix is 1 row and 2 columns. And then the next one is 2 rows and 2 columns. They are not the same size, and so they cannot be added together. In the next example, we are going to work on scalar multiplication. Scalar multiplication is basically the distributive property. So what it means is we are going to multiply the 6 times each of the elements, and that will be our new matrix. 6 times 2 is 12, and it goes in the upper left position. 6 times 8 is 48 in the lower left. 6 times -3 is -18 in the upper right. And 6 times 4 is 24 in the lower right. If we combine two different operations together, we would multiply first and then we would add. So our first matrix is simply going to multiply each of the elements by -1, which changes their sign to its opposite. Then, after we've done that, we're going to add the two matrices together, and we can add them because they are the same exact size. Their size is 3 rows and 2 columns, so they are the same size. So when we are adding those together, remember you add the same position. So -4 plus 3 would be -1. -3 plus 9 is 6. -2 plus 1 is -1. 7 plus 6 is 13. -3 and -8 are -11. 9 plus -4 is 5. So we did scalar multiplication and we did addition. In the next example, we want to solve an equation, okay? So the first thing we're going to do is we're going to make sure that we understand that we have to multiply 4 times each of these. But I only want to solve for where the x is. And the x is in the upper right-hand corner. So 4 times 0 would be 0, plus 4 times -2 would be -8x, and that's going to equal -48. So I'm only doing the part that's in the upper right-hand corner. And once I do that, I can solve the equation by dividing both sides by -8. And so x is equal to 6. Now I want to figure out what our y value is. So the y value is down here in the lower right position. So I'm going to distribute. 4 times 2y is 8y. 4 times 6 is 24, and that equals 8. So I'm going to subtract 24 from both sides. 8y is equal to -16, and then I'm going to divide both sides by 8, so y is equal to -2. Now, what we're going to ask you to do is to finish the 5 student examples for when we return, which are on adding, subtracting, scalar multiplication, and combination, and then solving.